I'm going to do a quick overview of dot diagrams. A dot diagram uses the symbol of the element to represent the non-valence electrons as well as the nucleus. So I'm going to use some unknown element X. So that's its symbol. X doesn't actually exist. It's just going to be a stand-in for an actual element. And then we're going to start placing the valence electrons. We're going to assume that this one has all 8 valence electrons, so you can see the order that we put them in. The first one's going to go on top, and so is the second one. Then we're going to move to the side where we're going to put them in one at a time on each of the remaining 3 sides before we put in the last 3. And now it has all 8. So we started 1, 2, 3, 4, 5, 6, 7, 8. And that's because these 2 represent the ones in the S sublevel, and then these represent the P, the other P, and the last P orbital. Remember, they exist in the X, Y, and Z planes, so that's why there are 3 of them. So let's do an actual element now. I'm going to go ahead and pick one from the periodic table. I'm going to pick a non-metal, so it's a little harder. We're going to do fluorine. And fluorine, if you look at its electron configuration here, has 7 valence electrons. Remember, we're only going to put dots for the valence electrons, or the outermost electrons. So I'm going to put that away. So we're going to put in F. Now that's the symbol for fluorine. It's going to represent the nucleus and all non-valence electrons. And then we're going to draw in those 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. If you didn't do it in that order, that one might not be wrong. So I want to do another one where you'll see why it's super important to always do it in that order. And we're going to do it for nitrogen. Here's nitrogen here, and it has 5 valence electrons. So I'm going to start, oh, interesting, I didn't even know I could move that. Oh, look at that. So now we're going to put nitrogen. Again, the symbol is going to represent the nucleus and all the non-valence electrons, and then we have to put the 7 valence electrons, keeping in mind the order that we added them that we had up there. So we're going to put the first 2 on top, and then 3, 4, 5. So we end up with 3 unpaired electrons, and that's going to become very significant when we do bonding. If you had just started putting 2 on each side, you would have only had 1 unpaired electron, and that's not what actually happens with nitrogen. It can actually make 3 bonds with another nonmetal. So it's really important that you know how to draw these dot diagrams.